Okay, hello everyone. Today we're going to be talking about scattered spider. We're going to be talking about threats to hypervisors and ransomware threats to hypervisors. So I'm going to go ahead and share my screen. Okay, so I'll start by just saying a little bit about Valley Cyber, a little bit about what we do and who I am. So I'm Austin Gadian. I'm the CTO and co-founder of Valley Cyber. And Valley Cyber started based on my time while I was in the United States Air Force. So I was responsible for securing satellites, satellite ground systems, and satellites in orbit. And it turns out the operating system that runs on most satellite systems is a Linux operating system. So I was doing a lot of defensive Linux security during my time in the Air Force, and I ran into a lot of challenges with the existing commercially available tools for protecting Linux systems. They had issues with performance, stability, security, and really detection efficacy as well. They weren't really good at detecting attacks on Linux as well. So based on that experience, we started Valley Cyber, and Valley Cyber started as a Linux security company. As we grew, we started to focus more on hypervisors than just general Linux. Of course, we'd still do general Linux security, but we're more focused on hypervisor security as a company. And there are many reasons why this decision was made, but one of the big reasons was just the way the attacks have changed. So there have been many attacks against hypervisors, in particular ESXi hypervisors, in the past few years. And so we're going to be talking about a threat actor in this presentation that's been very prolific in their attacks against hypervisors, particularly in this year, but they've been going after hypervisors since 2023 was one of the first big attacks. So we're going to be talking about scattered spider. And this year, scattered spider has done a ton of damage across a lot of different companies when it comes to ransomware attacks on the ESXi systems themselves. And typically when threat actors are going after ESXi, the goal is to encrypt all the virtual machines that run on top of the hypervisor. The reason an attacker wants to do this is it's a very devastating attack to an enterprise and a company. When this happens, the attacker is likely to get some sort of payout, some sort of compensation. So obviously, it's a very financially motivated attack. And Scattered Spider has been involved in many different breaches across many different industries. So Marks and Spencer got hit this year, the co-op got hit this year with attacks that cost hundreds of millions of dollars in lost revenue and damaged the organization. So they're very costly attacks. Now, if there are any folks on the call that are joining us from the government sector or from the defense industrial base and government contractors, I think there's another sort of attack that happens on hypervisors that's worth talking about as well, although it's not something that Scattered Spider does too much. It's an attack where the threat actor likes to dwell on the hypervisor. So they'll use the hypervisor sort of as a beachhead to launch further attacks into the network because they recognize most ESXi systems out there are not being monitored very closely. No one is really paying a lot of attention on to what's happening on the hypervisor operating system itself. You might be looking at the VMs, paying attention to the VMs, but you're not really looking at the applications and processes running on the hypervisor. And so this makes ESXi a big target for threat actors, whether they're going after more sophisticated attacks where they're trying to steal data out of corporate networks, or attacks like Scattered Spider where they're trying to encrypt data on virtual machines and on hypervisors. And Scattered Spider, it's interesting to note, they're sort of the organization that gets the headlines when it comes to these attacks. And so if you research Marks and Spencer or WestJet or some of these other breaches that have occurred, you'll see Scattered Spider named as the threat actor that really perpetrated the attack. But in reality, they fit into a broader ecosystem. This is something that some folks don't necessarily understand, where these threat actor groups operate a lot like companies. So they'll specialize in specific areas. Scattered Spider specializes in getting initial access into networks. So their goal is to gain initial access and to do lateral movement to find weak parts in the network, like the hypervisor environment, and then launch further attacks from there. And they'll typically team with a ransomware gang, groups like Dragon Force or Shiny Hunters or Ransom Hub. The ransomware gang is actually who deploys the ransomware on the hypervisors themselves or onto workloads and VMs. Scattered Spider is more about getting the initial access and doing lateral movement to that virtual machine network that's accessible. So we're going to talk about one of these attacks. The attack happened in 2023. It was a breach against a major casino group called MGM. And It involved this technique that we were talking about of lateral compromise, where the attacker initially gained access to the network and they found their way into the VMware portion of the network. There was about $100 million worth of damage reported with this breach, and it led to a settlement of about $40 million from a class action lawsuit. And that was just the settlement. It doesn't account for any legal fees that MGM had to pay. So this was a very expensive breach for MGM, and we'll sort of describe how this works and how it happened. So what Scattered Spider really likes to do when they're going after networks is they really like to go after initial access vectors. And in particular, what they're trying to target will be support help desks. They like to go after either internal support help desks or third-party support help desks. And they'll use a couple different techniques to trick the help desk into giving them a credential or a password to get access to the network. And so in the case of MGM, they use something called a SIM swapping technique. And so SIM swapping basically allows you to sort of fake a phone number for a legitimate phone number. So they call in with this fake phone number. They say, hey, I am this IT admin and I need a password reset because I've forgotten my password. And so these IT help desks, they're dealing with requests like this all the time, hundreds of requests, thousands of requests a day. So something like this, it can be difficult to know if it's out of the ordinary or not. So often it's a very successful social engineering technique where the threat actor fakes a phone number and gets the information from the IT help desk. And this is what happened in the case of MGM. In more recent attacks, Scattered Spider has also used AI to mimic voices. So if they can find a recording of a technologist or an IT service person inside of an organization, they will try to fake that voice as well as the phone number. So it's a really good fake. And so it can be very hard for these help desks to determine if it's a fake request or if it's a legitimate request coming from a legitimate user. And so once they do this technique to get the initial credential, they'll typically go after cloud services and they'll move laterally through cloud environments. Now, the reason they like to go through cloud environments is because they can navigate just using APIs. They don't actually have to launch any sort of malware on virtual machines or on workstations that might be detected by EDR tools. They like to operate in the cloud because they can just use the cloud service provider APIs to move around and gain access to other things in the network. And eventually, in the case of MGM, they found their way into the VMware network. And so what attackers love to do once they gain access to VMware networks is they just love to act like a normal system administrator. So they're not trying to do anything really fancy to get that initial access. They're just trying to fake their way through the network, masquerading themselves as the legitimate IT administrator before they launch their attack. And so in the case of VMware, once they have access to vCenter, they've stolen a credential for vCenter, they'll log in. Typically what they'll do is they'll turn on SSH for the underlying ESXi host that they'll launch the ransomware from there. And so we'll see an example of this in this video right here. I'm going to go ahead and assume the attacker has stolen a password for vCenter. They're going to log into vCenter from here. They're going to be targeting one of the ESXi hosts that's under management. And we'll be doing this change to the SSH setting through the user interface, but often it's scripted over PowerCLI when the attacker is actually launching the attack. But in this case, we'll just do it through the UI. We'll turn on SSH and we'll go over to the virtual machines. The goal of the attacker in this demonstration is to encrypt this Walter White virtual machine. It's just a small Ubuntu system that we're really going after. So they're going to use the stolen credentials to SSH into the system, and they will CD over to the VMFS volumes into the data store that's associated with that virtual machine. And so from here, what they're going to do is launch the ransomware. And when they launch this ransomware, they're going to do something a little bit sophisticated. So I'd like to talk through this. This is an example of a living off the land attack. So living off the land attack is one where the threat actor is going to try and use tools that are already located on the hypervisor to attack the hypervisor. So rather than trying to download malware and run malware on the ESXi host, they're just going to use what is already there to attack it. So what is already present on every ESXi host that's out there are the tools grep to list out files, OpenSSL to do file encryption, and then RM to do deletion. So if you put all those different commands together, you can essentially get a fileless ransomware attack. So it's a ransomware attack that's just using the commands available on the ESXi host to do ransomware. And so you can see if we're listing out files, we're deleting files, we're encrypting files, you can see how that can lead to a ransomware attack. And so when we run this command, it's going to go through all the files associated with this Walter White VM. And we'll see they now have this little nuclear extension at the end. This is because they've been encrypted. They've been renamed with that encrypted extension. If we try to run the virtual machine, it's not going to run. And so this is a very bad day for a system administrator that's trying to deal with this system. Your VM has been encrypted. And when these attacks happen at scale, the attacker will script the SSH turn on. So they'll turn on SSH using PowerQury. They'll also script things like changing passwords. So if they have access to vCenter, they can try to change the root password on the ESXi host themselves. And then they'll log in, they'll script the login. They'll basically do everything very quickly in a scripted fashion. And so I think what this means for defenders is that the traditional techniques that we've used to defend our virtualized environments are important. We should continue to use them, but they're not sufficient because attackers have recognized that if they just masquerade themselves as a system administrator and they use common techniques like social engineering and like phishing, they can find their way into VMware environments in a relatively straightforward manner. And the typical approach that's been used to protect hypervisor environments has been the security approach that was very common pre-2010. And so it's this approach where I'm going to create this very difficult to cross moat around my environment, and I'm going to protect my environment this way by segregating it off. It's going to be very hard to get to. And if you're in the environment, you're going to be able to do a lot of different things that you might want to do. But as long as you're outside of that initial barrier, it's difficult to gain access to the underlying hypervisors. And we do this with network segmentation, with firewalls. And the challenge is this approach doesn't work well when the attacker masquerades as the legitimate user. When they pretend to be a legitimate system administrator, they'll just walk through the same doors that your system administrators use to access the virtualized hypervisor environment. And so firewalls are great. You should definitely use firewalls to protect your environments, and you should do network segmentation. But when attackers are taking these approaches to bypass these defenses, we can see that they're not sufficient. Another technique that can be sometimes recommended to protect hypervisor environments, I actually haven't seen it used that much myself, but it's where we want to monitor what's happening on the ESXi system. And what we're going to do to achieve that is by taking syslog data off the ESXi hypervisor, we're going to parse the logs and analyze the logs. And if something strange happens, like an SSH session gets started that we don't recognize, then we're going to take some sort of action. And the challenge with syslog on ESXi is if you have an environment of any sort of scale, those logs get very large very fast. And there's a lot of data in the syslog that is not relevant for security purposes. So there's a lot of data just related to system startup, resource usage, CPU usage, memory usage, that isn't necessarily security relevant. So it can be difficult if you're using a SIEM that's charging you based on the amount of data that you ingest. It can get expensive to try to ingest all these logs. And you also have to have the appropriate rules set in place to parse through the logs and to detect the behavior that might be associated with an attack. And so these are some of the challenges with existing defenses. That's not to say that firewalls are bad. Again, you should use firewalls, but there has to be a better way. There has to be a better way to defend our hypervisors if an attacker is able to get access to them. And the answer to that problem is runtime security, some sort of runtime security solution that can be active on the hypervisor to protect it and detect malicious command usage and block malicious command usage. And so our solution for this problem is called ZeroLock. ZeroLock is the first solution of its kind for ESXi. It's a ransomware protection solution that will run on the hypervisor itself and protect it from attacks. We also support any sort of Linux-based hypervisor. So Proxmox, Nutanix, KVM, any sort of Linux-based hypervisor is also capable of being protected with ZeroLock. And ZeroLock is certified by Broadcom. So we've gone through the Technology Alliance program at Broadcom. We're a Technology Alliance partner. And this allows us to get our VIB certified and digitally signed by Broadcom. And that's key because typically you might see third-party solutions delivered as community-supported VIBs. And that's not great for security. It's not a recommended practice to use an unsigned VIB. So our VIB is actually signed by Broadcom. And the VIB is the vSphere installation bundle that you actually use to install the solution on your ESXi hosts. And we're certified on version ESXi version 7 and above. We do support all the way back to 6.7. The reason we're not certified on 6.7 is because Broadcom doesn't support 6.7 anymore, so they don't certify on it either. Okay, so let's talk about how deployment works. So deployment is very straightforward. If you're familiar with deploying virtual appliances in your ESXi environment, then deploying ZeroLock will be not a whole lot different. So essentially, we have a management console that's used to manage the agents that run on the underlying hypervisors. And this management console is deployed on top of a Photon operating system virtual machine. So you deploy that Photon OS image, and you will deploy it as a VM in your environment. It requires about 6 CPU cores, 16 gigs of RAM, so it's not a very heavy management console. And then from there, you can deploy out your agents. Now, this solution works totally air-gapped. So if you do have your hypervisor environment segmented from the public internet or from the rest of the internet or from your corporate networks, that's fine. That's not a problem at all, because ZeroLock is doing all of its detection and protection on the actual ESXi system itself. There's no cloud lookup or cloud data analysis that's happening on the back end. And after you've deployed this solution that can be deployed air-gapped, you will deploy the OVA, and then you'll download the installation packages for the agents. You'll upload those into vCenter, then you apply them to your ESXi host, just like a standard ESXi update. So it's very straightforward to apply the agent to systems. You just do it like you would normally update your ESXi hosts. And it's also worth noting that we are a solution that's focused on a specific problem. So we're focused on protecting hypervisors. We're not a solution for your entire security challenges in your organization. So we have to fit in whatever SIEM or SOAR that you might be using. So we do this with a very simple plugin that we have. It's an HTTP transport forwarding service, which will just forward all the logs and all the alerts that are generated by our system off to any sort of SIEM or SOAR that you might be using and that your security operations team might be using. And there's a question in the chat, is there a reboot required for the agent install? And there is, and that's required by Broadcom. So if you want to have a solution, third-party solution certified by Broadcom, and you want it to be signed by them, you have to require a reboot for that solution to be installed. And so you would apply this update to your ESXi systems during a normal maintenance cycle for your ESXi hosts. Okay, so now let's talk about the value that the solution provides. And so we demonstrate this with what we call the defense in depth slide. We also call it the onion slide. It shows us the different layers of protection that ZeroLock provides when it's deployed on hosts. Now, we do also need to note that the agent's very lightweight. It only uses about 50 megs of RAM, less than 5% of one CPU core, so it shouldn't have any sort of performance impact on your ESXi hosts. And the first layer of protection that we provide is SSH MFA, or multi-factor authentication for SSH. So let's go ahead and see this in action. So what we have here is the console for ZeroLock. So we can see different alerts across different categories there at the top. We also have a list of recent alerts. And if we jump to the endpoints page, we can see different hypervisors that we're protecting. Now, what we can do is jump over to the list of virtual machines. There's Frodo, Gimli, Gandalf. Those are the 3 VMs that the attacker is going to be going after. And they'll try to SSH into the hypervisor using a similar method as last time. They've stolen the password. They want to use that stolen password to log in. And so here, they don't actually get the login. They have to go through an MFA process with ZeroLock. And so they have to put in their ZeroLock credentials. They have to put in an authentication code. And only then do they actually get access to the hypervisor. Now, we use a simple time-based token to do the MFA. So you can use Google Authenticator or Okta or Duo, any of these common authenticators that you might be using to log in to your generic web apps or any sort of app that's using a MFA system. We can support that sort of MFA authentication as well. It's also worth noting that during an attack, your network might not be reliable. So let's say you're under attack, your network is not reliable, and you're worried that, hey, am I still going to be able to log into my ESXi hosts with this MFA protection in place? And the answer is yes. You will still be able to log in. It's because the MFA authentication is done all on the ESXi host itself. So all the authentication algorithms and processes run on the ESXi host. There's no network lookup that's required to authenticate with some third party MFA provider. All the MFA provision is done inside of ZeroLock. That configuration is pushed down to the agents, and once the agents have that configuration, they will let you MFA in, even if they are cut off from the management console or from the broader network in your environment. So this is a very effective technique for stopping just generic passwords being stolen or data being stolen from the environment where the attacker has done some sort of phishing or some sort of social engineering attack. Okay, so the next layer of protection is something called application filtering. So application filtering is this idea where we only want certain applications to run on the hypervisor. It's an appliance, right? So we don't have a whole bunch of different new applications running all the time, changing applications. There's a very standard workload that runs on the hypervisor operating system. And so what we're going to do here is do an inventory of everything that's installed on the ESXi host and whether it's been installed through a certified bib or not. We're only going to allow those programs and those scripts to run. Now, this is a similar capability to something that's native in ESXi called exec installed only. The key difference, or one of the key differences, is that this application filtering capability, it will extend to scripts as well. So if the attacker tries to download a malicious script, they try to use that script combined with other tools that might exist on the ESXi host, like OpenSSL or like RM, to do ransomware, we can still block that malicious script. It isn't just tied to ELF binaries or malware binaries that someone might drop on the ESXi host. So let's see the application filter in action. Here we're assuming the attacker has somehow bypassed MFA. Now they have access to the hypervisor and they're going to try to download and run some malware. And so this command that we're running at the top is first wget to download a ransomware sample. Then we'll use chmod to make that sample executable. Then we'll actually try to run that ransomware on the ESXi host. So we'll run those commands. And when we do that, we can see the attacker was kicked off the box. The connection was closed. So that is ZeroLock in action right there. So if we go to the alerts page, we can see a list of recent alerts. There was an alert about a blocked executable hash. This was the application filter in action. We also see the file system access and the process tree. So the process tree is really useful. It shows us the lineage of the attack, starting with it init all the way down through SSH into ultimately the defrayed ransomware that was run on the ESXi host. So we see the full command line arguments, the full executable hash information, all the data a threat intelligence analyst or a SOC analyst might want to see about an alert. That's going to allow the SOC and the security team to respond appropriately and have that intelligence and threat intelligence background to know what happened and what led up to the attack. So there are a couple of questions in the chat. I'll go ahead and answer a few of them. What is the overhead of the agent running on ESXi? The overhead is about 50 megs of RAM and less than 5% of one CPU core on average. So very lightweight, shouldn't have a significant performance impact. Let's see, what else do we have? Hyper-V support. So we don't support Hyper-V. Hyper-V is a Windows-based virtualization layer. We don't do Hyper-V support. We do support for Linux hypervisors and for ESXi. And then question about, are the VMs in powered off state? What about same thing with powered on VMs? Will there be any benefit of using KMS to encrypt the DS like vSAN, et cetera? So it's definitely worthwhile to use KMS to encrypt the data store and vSAN. The benefit of that is it prevents the attacker from necessarily stealing the data and just exporting it and trying to read it in their environment. This is something that ransomware actors will try to do, is they'll try to pull data off of the hypervisor and they'll pull VMDKs or data off the hypervisor, then they'll steal it and they'll have it in their environment. And then if you don't pay the ransom after they've encrypted your data, they'll threaten to release this information publicly. And so they sort of extort you in two different ways. They extort you by trying to encrypt your data, and they extort you by stealing your data and trying to release it publicly. So certainly encrypting the data and encrypting the data store is definitely worthwhile if you're going to use KMS. The other thing to note, though, is that if you're using KMS, it's not going to prevent the actual ransomware part of the attack. So if the attacker encrypts data that is already encrypted, that data is still unreadable to the KMS system. So if you do another layer of encryption across the encryption that KMS does, the data is still not readable, your workloads are still not going to work, you're going to have downtime. It's still going to be a challenge, but you're not going to have to worry as much about data being stolen out of the environment, which is a good benefit. And then there's a question about, are the VMs in these demonstrations in a powered off state? What about VMs that are powered on? This is a great point because when VMs are powered on, the underlying VMDK file is locked. So it's in a locked state, and the attacker can't actually encrypt the VM while the VMDK is locked. And so what attackers will do, one of their techniques after they SSH in or they log into the ESXi host, is they'll just power off all the VMs. And there are a variety of ways to do this. You can do it with just a kill command. You can do it with ESXi. There's a power off all VMs command available on ESXi. So you can just shut off all the VMs, and then you can run your ransomware. This is a very common technique that's used by threat actors, and it's something that Zero Lock detects. So if we see someone trying to kill VMs from the command line, it's something that Zero Lock will block. So I'm going to continue with the demonstration because there are a couple questions, and we'll come back to questions. But the next layer of protection I want to talk about is lockdown rules. So lockdown rules are fine-grained access control rules that allow us to define what applications are allowed to run on our ESXi host, what files those applications are allowed to access, and what network resources apps are allowed to access as well. So they really allow us to lock down what is allowed to happen on the ESXi system. And so they enable a lot of really cool capabilities. One of them is an anti-tampering capability. So you can imagine if an attacker recognizes that your hypervisor is protected by ESXi, they're going to want to shut it down. They're going to want to shut down the security before they can actually launch their attack and launch the ransomware on your host. And so lockdown rules enable anti-tampering, which I'll show you now. So what we have in this example is a PowerShell script, a PowerCli script, where the attacker is going to just try to uninstall Zero Lock from the system. This would be something that they try to do before they launch the ransomware on the system. And so the login.ps1 there at the top of the screen, that script is just going to log into the ESXi host. And then we're going to do a simple ESXi command over PowerShell and over PowerCli to try and uninstall and shut down the protection. So let's see what happens when we do that. So we'll go ahead and we will try to run this PowerShell script. And when we do that, it takes a little bit of time to log in. It's going to log in. We can see we've successfully logged into the host. And then it says, hey, I got an error code. I got no return value. This command to shut down and uninstall the component didn't work. And so if we go to the alerts for Zero Lock, we can see a new process tree. This time the attack was coming from host D. So host D is the application on ESXi that runs all the different PowerCli commands. So if an attacker tries to use PowerCli to do malicious things on your hypervisor, like uninstalling Zero Lock or something else that might be done through PowerCli, Zero Lock is capable of detecting those attacks and blocking them just like we've done here. And the particular operation that we stopped here was just an attempt to uninstall Zero Lock using the ESXi API over PowerCli. Okay, so lockdown rules enable a really cool capability called virtual patching. Virtual patching is the ability to allow a mitigating control to be put in place for a CVE or for an exploit without actually patching the system. And so let's see what this looks like in action. So go ahead and jump over to next demo. And lockdown rules are rules. So they're basically JSON structures that define the rules. We come with about 180 of them out of the box. You can create your own rules if you want, if you have a team that's skilled in this. In this example, we have a rule that is going to prevent VMX from running certain commands. So we're going to prevent VMX from running shells or running wget or running malicious commands that VMX should not run. And if you're not familiar with VMX, it is the process on ESXi that actually runs virtual machines. And so what the attacker is going to try to do here is an escape to host exploit. So the goal of the attacker is to break into a guest VM, and then from that standpoint, navigate into the hypervisor using an exploit. And to see this, we're going to go ahead and log in to a Ubuntu virtual machine that's running on top of our hypervisor. So we'll go ahead and do that. We'll log into our virtual machine. We will try to run our script, which is going to run the exploit itself. It's a CVE from earlier this year. from March of 25, and we can see we got a new alert. This new alert was triggered through the VMX process. So we saw that the VMX process was tampered with if we jump over to the process tree. So VMX in this example, it tried to launch a shell, and that shell tried to launch a reverse netcat session, which we'll see here. So we see the command line arguments for the VM that was run. It's a photon-based VM. And then we'll go ahead and jump over to the VMX command that was run. This is a netcat command. So the goal of the attacker in this example is to try and launch an outbound network connection back to their command and control infrastructure, potentially to download malware or to do something else on the ESXi host. But the point is, the VMX is supposed to run VMs. It's not supposed to run netcat. It's not supposed to run wget. It's not supposed to do all this other stuff that's associated with an exploit. And so by having this behavioral detection and these rules in place, we can essentially lock down what applications are allowed to do. So if they do something that's associated with exploitation, we can block it. So just to spotlight virtual patching and talk about it a little bit more, because it's a very popular capability of ZeroLock. There were 3 patches that came out in March of this year, all related to different CVEs that led up to an escape to host exploit that was executed in the wild. So attackers had an exploit. They were doing a memory corruption attack to go from a guest VM into the hypervisor itself. And what ZeroLock is going to do in this case, it's not going to patch anything. It's not going to change any code. It's just going to look for the behavior that's associated with exploitation, and it's going to block that behavior. The beautiful thing about this is if your team has to deal with a new CVE comes out, maybe there's a new high CVE that comes out, you have to deal with it. You don't have to run around like your hair's on fire every single time. You have a mitigating control in place through these lockdown rules and through virtual patching that allows you to prevent exploitation of CVEs. And the beautiful thing about it too is it's very future-proof. So think about CVEs, there's usually a vulnerability, and there's a new CVE comes out, and there's a vulnerability, and there's a new CVE comes out. And what virtual patching does is it looks more at application behavior. So VMX in this demonstration example that we just saw, it gets targeted for these escape to host exploits all the time because it's the application that runs VMs. And if you want to escape to the host from a VM, you have to go through VMX. And so if we just lock down what VMX is able to do, we get benefits not only for specific CVEs that like these that came out in March, but future CVEs that might target VMX in the future. Okay, so with that, I'm going to go ahead and talk about the last layer of protection. So the last layer of protection is AI behavioral detection combined with automated remediation. So this is where the attacker has bypassed all these other defenses, the lockdown rules, the application filtering, the SSH MFA, and now the attacker is just going to run the ransomware, and we have to still stop it and detect it. And the way we do this is by bringing a few very small type AI models that define behavior associated with certain types of malware. And so in this example, we have a model that will detect ransomware in particular. So we have a ransomware detection engine. Let's go ahead and see what that looks like in action. So the attacker is going to run that same living off the land attack that we saw earlier. They're going to use grep to list out the files for this Gandalf VM. They're going to use OpenSSL to do the encryption, and they're going to use RM to delete the files. And it takes a few seconds to run because we're actually encrypting a real VMDK. It's a large file. But as this command runs, eventually the attacker is kicked off the box. And this was the ransomware detection engine in action. Once we jump over back to the alerts, we can see a new alert about a ransomware attack. We can see the files that were affected by the attack. So in particular, we see the VMDK file was impacted by this attack. We see a new encrypted version of the VMDK file that was created. The original file was modified. And in the process tree, we'll see the commands that were run to execute this attack. So if we expand the process tree, we can see the OpenSSL commands, the RM commands that were used to do the encryption and to do the deletion. So now if we try to power on the Gandalf VM, it doesn't work because the VMDK has been encrypted. So this is a bad day. If you're a system administrator, good thing ZeroLock has an easy button. So it's that remediate button there at the top that we just clicked. What this will do is it will undo damage to the file system. So files that were encrypted are restored back to their pre-text state. Files that were created are removed from the system. And so now if we try to run this Gandalf VM, it runs fine without any issues. So we've got no problems running the VM. And for the purpose of demonstration, we sort of broke these into different steps. So you had to see the alert, you had to press the remediate button, and then the system was restored. But for production deployments, we have the system to automatically do the remediation. So the default configuration is we will automatically kick the attacker off the box and remediate or undo the damage to the file system if we see a ransomware attack happening on your hosts. And we're able to do this because the false positive rate is 0 for this detection engine. We have never had a false positive on an ESXi system from the ransomware detection engine, and that allows us to be very aggressive in the default settings for it. Okay, so a little bonus demo here. This is based on some data that came out of the London VMA. Christian Mohn gave a really good demonstration, if you're familiar with him, about ghost VMs. So ghost VMs are this idea where rather than running a VM through the UI or through the vCenter UI, the ESXi UI, I'm going to do it directly from the command line. And the nice thing about this from an attacker's perspective is these VMs don't necessarily show up in the user interface. So they can run a virtual machine on your hypervisor without you being to see it on vCenter, on the vCenter UI or on the ESXi UI. And so if we run this command that will attempt to run a ghost VM, we get kicked off the box. We get kicked off the box because of a lockdown rule. There's a lockdown rule that will block attempts to do and run ghost VMs on ESXi hosts. And this just shows you how generic and how broad the protection provided by the lockdown rule layer can be for different systems. Okay, so let's talk about what you can do to protect yourself. So one problem we have seen on ESXi hosts is that people expose them to the public internet. I don't recommend doing that. Do not have your ESXi host on the public internet. And so you can use a tool called Shodan to help you figure out what assets you have on the internet and what might be accessible to attackers just publicly. And there are specific queries you can do. So you can do queries on Shodan for ESXi systems, for vCenter, for vSphere. And if you create an account, you can also do it by a specific company that you might be part of. So if you're part of Walmart, you could do a search for Walmart's assets that are available on the internet. And Shodan's free to use. I'm not a Shodan sales guy. I don't get anything from advocating Shodan. I just think that it's really important to understand what assets you have on the public internet, and Shodan is a great tool to do that. And when you run through these checks, I hope you don't see something like this. So if you are to go on Shodan, and if you ran a very specific query, you would see that there are ESXi hosts on the public internet that have obviously been encrypted by threat actors. And this was found by our threat intelligence team. So we have a threat intelligence team that goes around, they find attacks, they do research on attacks, and they'll find things like this where attackers have run different commands on systems. And the great example here is that in the little ransom note for this system that's been encrypted, SSH was turned on and the firewall was disabled. And that goes with all the stuff I've been talking about, where attackers will typically go through SSH to launch their attacks, and they will typically disable the firewall as part of their attacks, or they'll bypass the firewall in some way. So with the holiday season coming up and with the year coming to a close, there are a few resources that are good for your team. There are a couple data sheets that we provide. So there's a technical data sheet that you could download there on the far right. On the far left, there's a data sheet that's really useful about making the case for hypervisor security. So how do I describe this benefit of this security tool in business terms to the executives in my companies? And the item in the middle is a blog post on a similar topic. So we got a couple minutes left. We can start answering some more questions. Megan, would you like to moderate?
You betcha. Hi, everyone. I'm Megan Howard. I'm the VP of Marketing for Vali Cyber. So excited to be here with you guys today. We've got just a couple minutes. And so let's dive right in. So first question is, are these VMs in a powered off state? What about same thing with powered on VMs?
Yes. So I think we talked about this one a little bit earlier. VMs in a powered off state are very common in these ransomware attacks because the threat actor is going to try to shut off the VMs. And that's because the VMDK file is actually locked while the VM is running. So the attacker will try to turn off the VM, and then they'll try to do their encryption attack. And ZeroLock will detect both things. So we'll detect file encryption, but we'll also detect attempts to kill VMs with the command line.
Let's see. There was also a question about, will there be any benefit of using KMS to encrypt the DS like vSAN and et cetera?
I think we talked about that question. Maybe the new questions start around multiple users for TOTP. So multiple users for TOTP. Yes, you can have multiple users with different authentication codes. That each user would have their own time-based authentication code, and they would be different time-based authentication codes. So you can absolutely set up multiple users in the zero lock system for the MFA.
Awesome. Next one is, I know you said only hypervisors, but what about vCenter, VCF, ops, et cetera?
Yeah, so the solution runs specifically on ESXi hypervisors and Linux-based VMs. We absolutely can protect Photon-based Linux systems as well, because that's where VCF runs. That's where the appliances that VMware provides run. The challenge is that there's no certification path for a security solution running on those systems. So you can't certify a third-party product to run on vCenter or on these other appliances that VMware provides. And as a result, you run into potential support problems. So we don't normally do that. We certainly can from a technical perspective, but from a product support perspective and working with Broadcom, it's not a preferred thing to do.
We are getting some questions regarding how this is licensed and about pricing. And so we're happy to have those conversations with you. We price per core. And so with a tiered system based on how many cores. So feel free to reach out to us at info@valicyber.com if you're interested in learning more about pricing. Let's see, there was another question regarding, does this work with NFS? Okay, or just VMFS? So that's a similar one to before.
Can you repeat the question, Megan?
Yeah. Does this work with NFS or just the VMFS?
I got it. So network file storage or just the VMFS? Yeah, it works with both. If you're using network file storage for your data stores, that'll work fine. And the rollback capability that I talked about, we run it from a data store. We also recommend you use NFS for that data store. That way it can be shared amongst all the different agents. You don't have to, but that's the recommended approach for setting that up. But yeah, we do support both VMFS based rollback or rollback on the NFS and protection for NFS and VMFS as well.
And what about ISCSI? Is that supported?
Yeah, iSCSI is supported. If you're using iSCSI to do your data stores, that's supported, and we can protect iSCSI as well.
Perfect. Shout out quick to Jamie Orth. He unfortunately said he's seen an attack from Scattered Spider in real time. Scary stuff. Really sorry about that, Jamie. We're seeing more and more folks being affected by Scattered Spider, and it's just truly terrible. So we're so sorry that you had to go through that. You know, let us know if there's anything that we can do to help. Let's see. Shane was asking if it's possible to get the slides. Shane, this is being recorded, and so it should be available to you after we're done recording. If you do want the actual slides, please reach out to us at info@valicyber.com, and I'd be happy to connect with you to get you those. Let's see. Somebody was asking if there's any trial licenses to do a POC. So actually we do have the for exclusive for VMUG. We do have the ability for you to apply for a license. And so I will put that URL in the chat right now. It's valicyber.com/VMUG. So feel free to fill that out and we can get back to you on that. Another quick question is, how do we protect from mistakes like CrowdStrike? So ZeroLock will never automatically push an update. Austin, I'll let you take it from there.
Yeah, so the question is about the CrowdStrike outage that happened a while ago that caused a lot of downtime for organizations. And first of all, ZeroLock runs entirely in user space, so we don't have any kernel modules or kernel components. So the risk of some sort of catastrophic outage like that, where we purple screen a bunch of ESXi systems, is very low. And to Megan's point, we don't automatically push out updates. So when updates are available, you get notified through the support portal. and then you can pull in those updates and apply those updates on your schedule. You can do appropriate A/B testing, but we're not going to automatically update your systems because that can lead to instability or issues like we saw with the CrowdStrike outage.
Awesome. Another question is regarding the zero lock component lifecycle. When the zero lock agent is deployed to ESXi, does this require patching, upgrades? If so, can that be done on the fly, or is the full reboot required? How often is the management appliance patched / upgraded?
Yeah, so we do a quarterly update process for both the management console and the agents. There are release notes associated with those updates. So unless there's a critical issue that's affecting your systems, or maybe there's a security critical issue, you're probably not going to need to update unless you want a new feature. Now, for the management console, the updates are just basically you pull down some container images and you update the container images on the virtual appliance itself. For the agent that runs on the ESXi host, we give you a new component, and you do have to do a reboot. So reboot is required to put this agent and the solution on your ESXi systems, and that's a requirement from Broadcom. So again, our solution is certified by Broadcom. It's digitally signed by Broadcom. We're able to protect the ESXi host from the operating system level because of that certification. And Broadcom requires that reboot so that resources and everything get handled appropriately once it applies the third-party package, our third-party package, to the ESXi system.
Great, thank you. Austin, did you answer Aaron's question regarding cluster-based images for updates?
I don't think I did, no.
Okay. I know we can attach the VIB to an image, but is there any additional configuration post update to, for instance, connect back into the control panel, ensure time-based token, etc.?
No, so all that's handled automatically. The data that's required to connect back to the management console is embedded into the component that you apply to the ESXi system. So we'll automatically connect back to the management console appropriately. And additional configuration like rules or MFA setup, all that gets pushed from the management console to the agent after that initial connection happens. So the initial connection portion is embedded, and then future updates are just done automatically through the management console and agent communications.
Perfect. Is there a separate MFA code per ESX host, or just one zero lock code used by all ESX hosts?
So it's based on the user in the zero lock system. So you basically have different users in the zero lock system, and each user will have their own time-based token. And based on what ESXi systems that user has access to, so you can basically group ESXi systems and only allow certain users to have access to certain ESXi systems. That will determine what users are allowed to access different systems via MFA. So let's say one group of systems is available to user 1 and 2. The other group of systems is only available to user 1. User 1 could access all the systems, but user 2 could only access the systems in the first group because they have access to those ESXi systems as defined by the grouping in the management console.
Thank you. Let's see. Is zero lock the appliance and agent tested, for instance, by Snike or other AI-powered static code analysis tools?
Yes, so we do absolutely use code analysis tools to make sure the code is verified. We use SonarQube, and there's another tool that I'm forgetting off. Oh, Veracode is the other one. So we use Veracode and SonarQube to analyze our code statically to make sure we're doing best practices. And we also have regular code review processes. So every line of code that gets added to the product is reviewed by at least 2 other developers. So we can prevent things like insider threats or backdoors being added to the product, and also to ensure that everything that's being added to the product is good quality. And I think the product they were talking about is called Sneak. It's another sort of static analysis tool. So Sneak is a great tool. We don't use it specifically, but we do use other static analysis tools. I think lots of funny names in the cybersecurity space.
For sure. Let's see. This is asking if I'm not sure we're going to know the answer to this one, Alexander, but we'll try. Broadcom, it's asking Broadcom isn't going to offer an authorized encryption protection as a standard feature for ESXi moving forward. Even Microsoft gives you the ability to disable BitLock.
Yeah, I can't speak to that. That's up to Broadcom's product management roadmap and deciding what features they want to add to the product. I think Paul Turner mentioned in the keynote today that they do have the ability to take in user feedback. So if that's a feature that you want, I definitely recommend talking to Broadcom directly, saying, why this feature is important, and perhaps they'll add it to the product in the future.
Perfect. Just a couple more questions. Is the control plane in the cloud, or can it be on-prem?
The control plane, the management console, can be on-prem. It can be totally air-gapped if you want it to be. It can also be cloud-based. So we do have customers running it in the cloud, but it's really up to you how you want the management console to be deployed. We recognize that you want your ESXi system sort of segregated from the rest of the internet. So if you do want it to be totally air-gapped and totally standalone, you can absolutely do that.
Perfect. And the last question that I'm seeing is it possible to use a third-party MFA like OKTA or Cisco ISE?
So you can scan the MFA codes with an Okta cell phone-based authentication scanner, and you can do it with Duo or Microsoft, any sort of those cell phone-based authenticators you can use. The reason we don't directly integrate with third-party MFA providers is because it requires an extra network lookup. So when we're doing the MFA process, the agent would have to reach out to that other MFA provider to actually validate if the MFA is legitimate or not. And the problem is that if there's an attack or a network outage and the agent is not able to reach out to the third-party MFA provider for some reason because the network is not reliable, then you're not going to be able to log into your ESXi systems. And so we've gone through sort of back and forth with our customers so far, and so far they've wanted to use the zero lock MFA capability because of that key reason. It's basically a robustness and a stability reason in the case of network stability issues or network outages.
Perfect. That's all the questions that I'm seeing today. Thank you everybody so much for joining us and for staying longer to get your questions answered. We're so happy to be here with you today. If you do have any additional...
there are a few questions in just the generic chat. Do we have time to get through those, or should we wrap up?
I had been going through those.
Okay.
Yeah, I had been going through those.
So there's one I don't think we answered about, instead of two-factor, why couldn't I achieve a higher level of security by using SSH keys instead of passwords? And so default on ESXi, the authentication method is to use passwords. Now you could set it up to use SSH keys, and that's better than using passwords potentially. But if the attacker steals the SSH key, they can still log into the ESXi host. The other challenge is that if the attacker is able to gain access to vCenter, then they can change the configuration of the ESXi host. They could add a new user that's using password-based authentication, and they could then log in with the password for that user. So yes, SSH keys can be more secure, but having that extra factor of authentication is still a benefit, whether you're going to use a password or an SSH key to log in. Let's see.
Thank you. And so if you have any questions or would like to connect with us, whether for partnering or direct sales or anything else, please feel free to reach out to us at info@valicyber.com. That's VLICYBER.com. Thank you so much, everybody. Oh, excuse me. Is the question number of hypervisors in your environment actually number of VMs or VM hosts? Lee, I'm wondering if maybe you're talking about pricing, but please feel free to clarify.
Yeah, so if you're talking about how we price, the pricing is based per CPU core. So we do a per core model. There's volume tier discounts, and so the more cores you have, the lower price per core you pay. If you want to talk about pricing, feel free to reach out to us at info@valicyber.com. And if the question is about how you deploy the agent, it's deployed on the hypervisor. It's not deployed on virtual machines. It's deployed on the hypervisors themselves.
Oh, I'm sorry. So Lee just clarified it was about the form. Number of hypervisors in your environment, VM hosts. So that's what we're referring to there, Lee. So thank you for the clarification there. VM hosts. So Thank you so much. Again, yeah, there is that film in that form in the chat, valleycyber.com/vmug, if you are interested in applying for a free license. We're happy to answer any additional questions you have at info@valleycyber.com. And this session is being recorded, and so it will be available for you and your team after the virtual event is over. So enjoy the rest of the day, guys, and thank you so much for joining us.
All right. Thanks, everyone. Bye now.